Okay, welcome to 1.3. In this lesson, we're going to expand on the stuff you learned on surface area in grade 8. So, we're going to start using pop cubes in the beginning of it. So, I don't know if you remember what pop cubes are, but this is what they look like. You're familiar with those, I'm sure. So, what we're going to do is we're going to go back to surface area. Now, surface area is the area of a flat surface for us in grade 9. And a flat surface is called a plane. So a plane is a flat surface. And it could be anything from a floor to a wall, the cover of a book, or it could be a face of a pop cube. So if you have one pop cube, and I've taken and drawn a cube here, and the edge length is 1 by 1 by 1. What is the surface area of that cube? Well, to find this out, you have to take and find the area of one of these faces. And since there are 6 sides, you take and find the one area and you multiply it by 6. Now, remember the area is length times width. So in this case, just to make it a little bit more clear, that's 1 by 1. That means the area of one face is equal to 1. And this would be units cubed, okay? So, units squared, sorry. Now, if there are 6 of them, that means 1 by 6 means that the surface area of the whole cube is 6 units squared. Now, if I take out another cube, we know that the first one we just calculated was 6. And if I put the other one with it, it's another 6. So together, they would be 12 units squared. But what if I slide them together? If I slide them together like that, you'll notice that the face that was here is now covered by this face right there. And they squish together and they're not visible. There's now a joint here, and this here plane that is between them is now not available. So we have one less face on each cube. Okay, we call this overlap. So if we take a look at it, we have the original first cube, the original second cube, and then we have one face on this cube here, which is not available, and one face on this cube here, which is not available. So now, instead of having 12 square units, we now have 10 square units. Now let's take a third cube out and put all 3 of them together. So now what I'd like you to do is I'd like you to guess what the surface area of 3 cubes put together would be. All right, well, we know that this is 6, and this is 6. Those are our cubes. We know we lose 2 here, 2 here. So it's 6 plus 6 plus 6 minus 2 minus 2. So we have 18, take away 4, that is 14 units squared. So why is the surface area of 2 cube train, this one here, not the same as that one? And the reason for that is that when the cubes are pressed together, or when linked together, you lose 2 faces, one on each cube. And on this one over here, you lose 4 faces on 3 cubes. Now this faces that we lose, we call them overlap. And we're going to use that in the coming up questions. So let's take a look at some possibilities here. Well, what I'd like you to do is if you have pop cubes, it would be nice. You could put them together in this shape, and then you could look at them, and then you can just count them. Now, I know you don't have pop cubes, so what I've done is I've taken and I've drawn all 6 views if you were looking at this particular object. Now, it's easier just to count them. You could go and try to break them all up and use formulas and everything, but because it's just pop cubes and they're all squares, for a figure like this, how many surface faces can you count? And that's what I'd like you to do. Take a second and see if you can figure out how many faces there are on that. Well, it's pretty straightforward. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So in this one here, we have 24. I guess it would be units squared. And it's easier if you have the cubes to do it with. Here's another one. If you can get this one and build it, and then take and count them. If not, see if you can figure it out. I'll give you a couple of seconds. Okay, so this one has 24 faces. So that means that the surface area is 24 square units. Here's another one to try. So pause the recording while you figure it out. All right, this one has 36 faces. So that means it has an area of 36 square units. Okay, pause the recording, build this one, and try to figure it out. All right, and this one has 24 again. And that gives us an area of 24 square units. Now, we're not always going to have pop cubes. We're sometimes going to have rectangles. So what I'm going to be doing here is I'm going to be going through a couple of things. First off, we're going to show you how to calculate the surface area by taking a look at every single surface. And then later on, I'm going to show you the formula, which does a whole box by itself. And there's a time and a place for both. Some people prefer to use the piece-by-piece method and then add them up all at the end. Others prefer to use the big large formula. It really doesn't matter what method you use, as long as in the end you can come up with the correct answer and show your work to prove it. So let's take a look at this one right here. How many faces does a prism have? Well, this is a right rectangular prism, so it has 6 faces. It has a left and a right, a top and a bottom, and a front and a back. 6 sides. Are they all the same surface area? Well, no, they're not. If you look at this right here, right now, our ends are different than our top and our bottom, so the area is not the same. Are there any that are the same? Yes. The ones that are paired opposite each other or face each other are always going to be the same in a right rectangular prism. So the front and the back will be the same. The left side and the right side will be the same. And of course the top and the bottom will be the same. So when we're doing this calculation, we need to calculate area of the front, double it to get the back. Calculate the area of the left, double it to get the right, and same thing here and here. So you only have to do 3 calculations, one for the front back, one for the left right, and one for the top bottom, and then you add them all together and you'll have your surface area. So since they're all rectangles, our formula is very simple, length times width. And yes, you have to use the formula, and yes, there should be an equal sign in between them. If you take a look, our front and back, this is our front and back right here. That means it is 38 by 9. So my area is going to be 38 by 9. So when you do 38 by, sorry, it's not 9. Back up for a second. Just made it. It's 38 by 13. Just looked at it and went, hey, wait, that's not right. All right, so 38 by 13, the front face. And that gives you 494. But there's one on the front. There's also one on the back, so we have to double it. That gives us 988. Now, the left and the right, they are the same. Now, if it's 13 tall here, it's 13 tall there. So here's my left and my right. It's 9 by 13. So again, put your formula down. And that's equal to 13 by 9. And 13 times 9 on your calculator is 117. Now, there are 2 of them, so multiply by 2, and that will give you a total area of left and right of 234. Okay, I want you to figure out the top and the bottom. So take a look and erase this part. Here is your top and your bottom right there. We know this is 38. If this is 9, that means that's 9 also. So calculate the surface area. Okay, so You're back, so the area here is 38 times 9, so your area is equal to 342. Doubling that means that you get 684. So now to find the surface area of the total thing, you've got to take in 988, the 234, and the 684, and you have to add them all up, and that will get you 1906. So that means that the surface area of this right rectangular prism is 1,906 millimeters squared. All right? Pretty straightforward. We did this last year. Now, the next part is to add the grade 9 part. Now in grade 9, what we're going to do is we're going to press two of these boxes up against each other. Now just like we had linking cubes that when we put them together, your two linking cubes had that area right here, which is inside, and that part was not available. The same thing is going to happen in here. If you look, you think about it, right in here, there is that rectangle between the two of them, right? And that rectangle is the same as the faces on a linking cube. It's pressed up against each other, and you can't have it. So you can't get at it. Now that area right here is the same as the front. Okay, so to find the area of the overlap, it's going to be the same as the front, because it will be the same size. The front and back are all the same. So could you calculate each of the objects separately and then add them together? Yeah, you definitely could. You could take and sketch each shape, and you could do each square, each rectangle. Okay, so you could sketch each shape and then add them up after you calculate them. Now that's a lot of work. So how could you calculate the surface area of this object without doing each individual side? Well, what we can do here is we can look at the overall views of this object and then take the outside of it. All right, this is the front view, and if you look at the front view, that rectangle holds the whole surface area of the front of the small box and the front of the big box, but it's still 38 by 32. All right, so to calculate this area, you just do the same thing we just did before. Area is length times width. Area is equal to 38 by 32. That means your area is 1216. So that takes care of the front view. Now remember, we have 6 views that we can work with, right? But the back view here is exactly the same as the front view, which means all we have to do is take the area that we just got, and this one is also this area. Sorry, the surface area is 1216. They're the same thing. It may not always be that way, but in this case it is. Now, the left side and the right side. The left side looks like this. Now, this is a little bit more difficult because I've got now this little box, and I got the larger box right here. So I'm going to have to split this up into 2 different rectangles. So I've got a small one, area is length times width, and that is 9 by 13. That means that the area of the small box is going to be 117. The area of the larger box is still length times width, and that's equal to, I got 32 by 9, and that gives me 288. Okay, so adding them together means that I get a surface area of 405. Now remember, this is the left side. The right side is exactly the same thing. So in this case, the right side is going to also be 405. Moving on, the top view and the bottom view. Again, this one's very straightforward. You don't have 2 calculations. You just have the one calculation, which is 18 by 38. So area is equal to length times width. Area is equal to 38 by 18. And that means when you calculate this, you're going to get 684. Now, bottom is going to be the same thing. So this is also 684. So now what we have to do is put all the pieces together. Okay? Now, pieces together, we have the top, bottom, left, right, front, and back. Now, let's see if I can get all these in here. 684, 684, 405, 405, 1216, 1216. Add them all up, you get 4610. And that is the surface area of that object. Fairly straightforward, fairly simple. But there is another way of doing it, and we're going to show you that a little bit later using the formula. So let's take a look at our next step. And that is where we have two boxes on top of each other, but we don't want to draw them and do the views. What we're going to do instead is we're going to take box A and box B. We're going to calculate their surface area, and then we're going to take a look at the area that is overlapped, like our pop cubes, and we're going to subtract that. Now remember, this one here is same 57 wide, and it is 27 on the side. So what we're going to do for box A and box B is I'm going to take and I'm going to change our notes a little bit. Rather than go through all of these, I'm going to introduce you to the formula that we use for one single calculation, and it makes things a lot easier. So the surface area of a right rectangular prism, and there's variations of this formula, but this is the one that we're going to use, 2 length widths, 2 width heights, plus 2 length heights. Now, all we have to do now is go back to our box A and identify what is the length, what is the width, and what is the height. So our length, if you take a look, is 57. So I'm going to go down here and go length is equal to 57. My width is 27, and my height is 44. All right. Now, the nice thing about this formula is, with your new calculators, once you have all the substitution correct, you can just push all the buttons, put it all together, and it'll all just flow out. So substitution is very important that you keep the numbers straight. I've got 2 lengths. My length is 57. My width is 27. Plus, I have 2 widths, so that's 27, times a height, which is 44, plus 2 lengths, a length is 57, and a height, which is 44. Now all that calculation in one shot in your calculator, if you're careful, will give you a surface area of 10470 millimeters squared. So you can see that all that extra work, top, bottom, left, right, up, down, all those things, we don't have to worry about it. We can do it in just 3 steps. So there is our surface area of our small box in one shot. Okay, let's go to the next page, and now we're going to have to do the area of the big box. So I'm going to do the same thing. I'm going to take and get rid of this. I'm going to put in this formula. Surface area is 2 length widths plus 2 width heights plus 2 length heights. So what I'd like you to do is to fill this in and finish this off and find out what the final is. So pause the button, pause the video, and do this. Okay, let's do the substitution. So our length in this case, if you take a look on the previous page, was 102. Our width was 36, and our height was 25. So now just put the numbers in. I'll get 2 times 102 times 36 plus 2 times 36 times 25 plus 2 times 102 plus 25. Doing it all in my calculator in one shot, and I'm going to get a surface area of a large box is going to be, let's see if I got this right here, 14244. All right, and we are in millimeters squared. Okay, so now that I have the surface area of the large box, our next step is to go back and remove the overlap. Now, if you go back and take a look at our picture a second ago, this is my overlap right here. It is a rectangle, and it's 57 by 27. And just like we had the cubes, which were stuck together, right? I don't know if you remember this, but you should. this surface right there. Remember, there's two of them that are pressed up against each other, and we have to remove them. So it's the same thing right here. We have to remove two of those, one for the bottom of box A, and then the part that it covers up on the top of box B. Now both shapes are 57 by 27. So here we go. So the area is equal to length times width, 57 times 27. So the area of one of those squares is 1539. Now remember, multiply by 2, and that means that our surface area is going to be 3078. Okay, so total surface area. Now we have to put it all together. Now because I've changed how we did things, things are kind of messed up here in our notes, but what we need to do is find the total surface area of both boxes. So my surface area is going to be the surface area of the first box, box A, which we found out to be, grab my notes here, it was 10,470. And of course, the large box we found out was 14,244. And we have to take away our overlap, which was 3078. If we do that, you should get 21636 millimeters squared. So there you go. That is the surface area of that composite object. All right, let's go. The next one is exactly the same, except now I have 3 boxes. Now, rather than do left, right, front, back, what I'm going to do is we're going to do the same thing. I want you to find the surface area of the 3 boxes and then stop, okay? So you have the spaces for all 3 boxes, the big one, the middle one, and the small one. Go through and do all of them, and I will we'll start the recording in a second, okay? Okay, so hopefully you've calculated all of them together. So to do that, the big box, again, what you need to do is to find the surface area. So get rid of this stuff here. The length, width, and stuff. So the length on the big box is 6, the width is 4, and the height is also, height is 1. You have to have these numbers correct or it's not going to work out. My surface area is 2 length widths plus 2 width heights plus 2 length heights. So my surface area is going to be 2 times 6 times 4 plus 2 times 4 times 1 plus 2 times 6 times 1. Put it all on your calculator. You should get 68. Okay? Now, let's go to the medium box, which you should have already finished. I don't know why that thing keeps popping up. My alignment's a little bit off. Okay, just give me a second here. I have a visitor. I'm going to pause this. Okay, so my visitor is now left, so we can continue. The medium box, again, same things before. I'm not going to be using this. I'm going to be using the formula. So for the medium box, my particular dimensions are my length is equal to 4, my width is equal to 2, and my height is equal to 1. So I've got those. It's just a matter of putting down the formula. 2 length widths plus 2 width heights plus 2 length heights. And if you try to remember the formula, it's actually kind of easy. It's 2 of these, it's 2 of these, and it's 2 of those. All right? So then putting in the numbers, it's equal to 2 times 4 times 2 plus 2 times 2 times 1 plus 2 times 4 times 1. So the surface area then, when you put all that in your calculator and you crunch it all up, you should get a surface area for the medium box of 28 centimeters squared. Okay? Now the small box is a cube. I don't know if you noticed that, but it's a cube 2 by 2 by 2. So we know that if you find the area of one of those faces, length times width, 2 by 2, that means that one of those faces is 4. Now, since all 6 faces are the same, you take the area of one of those faces, multiply it by 6, and you'll get the surface area of the whole thing, 24 centimeters squared. So now the last part is to put them all together, and that is 68 plus 28 plus 24 means that you have 120 centimeters squared of all 3 of them stacked up. But we now have to do the overlap, and that is the part of the boxes that are pressed up against each other. If you take a look at the medium one, let's just back up for a second, look at the medium one, you'll see that it is right here. All right, and it is 4 that way. And if you look very carefully, you'll see that this length right here is 2, so that makes that 2. So it's a 4 by 2. All right, so going back here, the medium, the big, the area, it's a rectangle, so it's length times width. And that means that the area is going to be 4 by 2. And that gives you 8. Now remember, there's 2 of them. That means that we have 16. Now, if you go back to the small one, it's a 2 by 2 by 2 cube, which means that one of those spaces is 2 by 2. All right, so formula is equal to length times width. Your area is equal to 2 by 2. That means that your area is 4. You double that, means that the overlap for the medium to small is 8. So now, my total surface area is 120. And now I have to remove the 16 for the first overlap and the 8 for the second overlap, which means that my surface area for this object is 96 centimeters squared. So there you are. That's how you find a double overlap, I guess. All right, so turning the page, this is the next and the final type that we can work with. Now, there are 2 ways of doing this. You can turn this into the formulas, surface area is equal to 2LW, etc. like that. And you could divide this up into two objects like this. And you could find the area of this here cube and this here cube. But you have to remember, if you're going to do that, then the surface area, you have to remove the floor, the basement, or sorry, the main floor. So the bottom of both of them has to be removed. Okay, and the surface area is on the top would also have to be removed. So it gets complicated, but it is much easier and more straightforward if you take a look at each one of these shapes and you just label each one. So if you take a look down here, you see what I've done is I've gone and I have labeled every face with a number, 1, 2, 3, 4, 5, 6, 7, 8. So what you have to do now is simply just calculate the rectangles and add all the rectangles up. So if you go to the next page, you'll see that I've got wall 1, 2, 3, 4, 5, 6, 7, 8. So what I'd like you to do is to try and find the surface area of every one of those walls and calculate them. And then what I'll do is I will then do them for you, and we can see how close we are. And hopefully we'll have the same answer. All right? So there you go. Pause the recording and do this. All right, well, you're back. They're all area is equal to length times width. Wall 1 is 5 by 4. That means that this wall is 20. Wall 2 is 8 by 5. That means that this wall is 40. Wall 3 is equal to 10 by 5. So that means that this wall is 50. Wall 4 is equal to 8 by 5, and that area is 40. Wall 5 is equal to 8 by 4, and that area is 32. Now, these should match what you've got. Wall 6, area is length width, so the area here is 14 by 8, so wall 6 is 112. Wall 7, area is equal to length width, area is equal to 16 by 5, area is equal to 80. And wall 8, area is equal to length width, area is equal to 14 by 5, area is equal to 70. So compare those. Hopefully all of your numbers match mine. It's very important that you find each one of those dimensions and label them so that you can figure out what the rectangle area is going to be. If you miss even one number, your total is going to come up be a different number than mine. So to add them all up, you should be adding 20 plus 40 plus 50 plus 40 plus 32 plus 112, 80, and 70, and that gives you 444. There you go. So that is the surface area of the whole thing, everything. All right? Now, the next thing we have to do is we have to go back to our diagram, And you'll notice that it says here, what is the surface area that has to be painted, including the roof. So you don't paint the inside floors, but we never included those in our calculation. But we have to take a look at the doors. You have two doors here. The walk-through door down here, which is 1 by 2, and then you have the garage door, which is 3 by 8. So we have to subtract those two from our surface area. So going down here, the door area is equal to length times width. This was a 2 by 1. So this one is 2 meters squared. The garage door area is equal to length width. Area is equal to 8 times 3. The garage door was 24. So to find the whole total surface area, you're going to take the 444, take away the 2, and take away the 24. When you do that, you're going to have 418. So the surface area, if you're painting this whole thing, including the roof, is 418. All right, so get busy on your assignment, and we'll see you in the next lesson.